Hello there, welcome to another science video. It's Science Mr. Robertson time for my Year 4 students. And let's try standing up. Let's see if this works any better. And also, those checkpoints, you will have them this time online on Google Docs, just underneath the video link on SchoolSoft. So check it out. Do that before the lesson. Let's see if this works even better. So, today, what I'm going to talk about is 3 different science ideas. You know about temperature. You know about temperature. You know about what happens when it's really cold. Because when it's cold, there's not much energy. They move slowly. And they contract. They get smaller and smaller. So there's contraction, and it's slower. The opposite of when it's hot. When it's hot, the particles start to expand, and they can vibrate, or they can move much faster. They need more space. We've done this in class. You're all very, very good at understanding this when I give you different examples. This is going to take it a little bit further today. A little more ideas. Because it's about how temperature moves. And how temperature goes from one thing to another. That's what we're looking at right now. The first new word I'm talking about is conduction. Conduction is in solids, a little bit in liquids, very, very tiny bit in gases, but it's mainly just solids. And it's really simple. Let's say I have a nice solid. Here's all my particles in my solid. And it is a bit of vibration. Tiny bit of vibration. It's quite cold. If I make it hot here, then these particles here get more energy. They start to vibrate more. And if one of them starts to vibrate, then the one next to it, oh, you bump, oh, you hit me, ah, and they have to vibrate more. And the next one has to vibrate more. So they all pass on energy, one person bumping into the next person, bumping into the next person. That is conduction. In a solid, when they're all squished together, they're all bonded together, as one gets hotter, the energy gets passed down the line. That's conduction. That happens best in metals. Metals usually are closer together, the energy can move easier between them. Conduction works very quick in metals. That's why if you put metal in a very hot water, the metal spoon or whatever it is gets hot very quickly. That's conduction. There's another thing about how energy moves, and that's going to be called convection. Very close, not the same. Convection. This works best in liquids and gases. Liquids and gas, it works best because it needs things that can flow. They need to be able to move. The best example of this you may find if you have a heater or something in your room. What happens is that if something is hot, expands. As you know, it needs more space. So it may start to go up. It's lighter. One atom, I need more space. I'm going to be lighter than the one atom needing this space with others close by next to it. So there's more than one atom in that space. So hot goes up to the top, and then cold goes back down to the bottom. It will contract. So you have air that goes up and down all the time. That's convection. The final word is radiation. Radiation doesn't matter which one it is. It needs nothing, in fact. Radiation, that is light energy. If light hits you, it has energy. If you stand in the sun, you feel more energy than if you stand somewhere not in the sun. The light has energy that makes you warm. The sun is millions of miles away up there in the sky, in the middle of our solar system. But the energy gets to me and makes me warm. There's no solids, liquids or gases in the way. Most of space is a vacuum. There is nothing there. But this still happens. So there's still light energy that hits me and makes me warm. We call that radiation. This is all very well and good. So there's conduction with the solids bumping in, the convection flowing around, and the radiation with light energy. All of this is important for one thing, which is insulation. Keeping us warm. If I want to keep me warm, I need to stop conduction. I need to stop convection. And I need to stop radiation. My question at the end of this for you is about a coat. You wear a coat in winter. It keeps you warm. How does it do that? Why does having a big coat keep you warm when if you didn't it wouldn't? How does this work? That's my question for you. Good luck to questions this week. We'll see if it works in online. Thank you very much for listening. Take care.